Hello and welcome. In this video, we're going to be demonstrating how we can implement one-way ANOVA utilizing Microsoft Excel. Now, I want to clarify the purpose of this video. If you're doing ANOVA professionally, I highly recommend utilizing a statistical software or some data analysis tool packs that are available within Excel rather than doing the method that we show. This said, I do want to demonstrate to you the method that we're showing so that you get a good feel for exactly what's going on behind the scenes when we conduct this ANOVA analysis. So I really want you to understand and feel comfortable with what we're going to be doing in the ANOVA, what the analysis means, what's going on behind the scenes, which is why we're going to break it out kind of piece by piece. So before we get started, one thing that I wanted to discuss in this lecture is that our data can come in different formats. I have in this Excel sheet that's available on Canvas, two different formats our data can fall into. One is labeled wide and one is labeled long. Now, both of these data formats represent the exact same data, but what's going on in here is how we organize our data. We have two variables, the health views of the participant and the dosage that they received, and then we obviously pair them together in some way. In this wide table, we have columns based on the dosage, and then every item in the table represents the health views of the participant for participants 1 through 10 and groups 1 through 3. In the long format, we have both of these represented as both columns are variables themselves, the health variable and the dosage variable, and each row represents a distinct participant. Notice in the wide data, each row doesn't necessarily represent a distinct participant, as in this first participant who was on the half dosage is not the same as the second participant who was on the full dosage, the first participant in the dosage 1.0 group. So depending on who runs your data, I find this format to be a lot more common for data to be stored in a systematic way. On the other hand, the wide format of data, which is just the reorganizing, I took all the 0.5 data and placed them here. I took all of the 1 data and placed it next to it, and then all the 2 data and placed it next to it. This is going to be a little bit easier for our computation. And there are some cases where data may be stored in wide format, again, depending on the type of data, especially if it's repeated measures data, where these are all observations. Each row represents a participant. In this particular case, that's not the case. We're going to use wide data anyway, because wide data facilitates the implementation of this process in Excel. Okay, well, now that we have all the background out of the way, let's go on and jump straight into this. So what I'm going to do first of all is I'm going to go ahead and I'm going to find the average for each group, the yi dot bar. So for the first group, I'm going to go on and type equals average. And I remembered the correct name here, average. There we go. Then I'm going to select everything in my first column, close my parentheses, and hit enter to find the average for this particular column. It's going to be that last row. Now I'm seeing actually this is a little bit complex, so I'm going to insert a new column and write average next to this so I don't forget that this last row represents the average. All right, now I'm going to do the same process for the next one. I can click the bottom right, or when I highlight the cell, I can scroll my mouse over until it turns into this dark black cross, and then click that and drag over to have the formula copy and update with the updated columns across. I could have also just typed equals average and then selected the C2 through C11 cells. So either way, to get the averages, and recall these averages are y I dot bar. This is the average for each group. This would be y sub 1 dot bar, y sub 2 dot bar, and y sub 3 dot bar representing the first group, the second group, and the third group. I'm just double clicking my column margin here to automatically size to the text in that column. Now, similar to how we constructed this in our lecture on chi-squared, I'm going to make a couple of other tables which will indicate the quantities that I want to calculate. Recall that there were three sums. I had the sum of total squareds, and actually now that I think about it, I should probably calculate the grand mean. We'll do that in a second. I had the sum of squares within and the sum of squares between. So it might be nice to write out the table of within values and the table of between values. And so we'll do that in a moment. Real quick, let's go on and calculate the grand mean. So the grand mean, recall, is the mean of all of our data. That's not our averages here. Actually, that would be the average of our averages, but I'll just go on, calculate average, select all of my data, not including these averages at the bottom, close my parentheses, and hit enter. And this is now my grand mean. It's just the mean of all of my data and my yi dot bars. So recall grand mean is also y dot bar. So all of my data here, take the average of all of it to get the grand mean. And again, for the yi dot bars, it's just taking for each group. This is y1 dot bar, the average for the first group, y2 dot bar, the average for the second group, and y3 dot bar, the average for the third group. All right, so let's go on, and now let's go on and make the within components. So here, recall for within, I take each data value and I subtract its group mean. So for this first one, I'm going to type equals, and I'm going to have this data value minus the group mean, and then we, if you recall, squared this difference. So I have y I j, which is the data value, minus y I dot bar, which is the mean, and then I square this. And now I'm going to do this for all of the different components. So I'm going to, in my next cell, do B3 minus the group mean, and then I will square that difference, add parentheses, and raise to the second power. Now, I will say there's a bit of a shortcut way. You could go and type each of these out. You would go to the second column, and this would now represent the second variable's data minus the mean of the second variable, and then add the squares. But again, there is a bit of a quicker way if we access one of Excel's features when using this bottom drag and paste feature. Now, if I drag this down, this is going to move not only the reference cell for the first part of the equation, the B3, but it'll also move the bottom cell down as well. So what I want to do is I want to lock in the second number in the bottom cell, so this is stuck at 12. What I can do to do that is to put a $sign before that number, and that'll tell Excel when I click on the bottom right and drag it down to keep that second cell the same, and you'll see this stays at 12 even when I drag it down. Now, what's nice about this is I can also drag this over to the right, and what's going to update is the B is going to become a C, but because I don't have a $sign in front of the B in this second value, the mean, now this is referring to C12, and now I can drag this down to represent all of the values in C. So here I have C11, which is this particular, and I'll click on it so we can see it. C11 minus C12 squared. So doing that $sign next to the 12, again, just saves me some time. Here I'm going to go up one so that I can get that top value, and I'll double check, click here, D2 minus D12, that is, I take the Yij, this is Y sub 3, group 3, J is 1, the first participant, so Y sub 3, 1, minus the group mean, and square that difference. Oops, hit escape so that I can back out of that. And then I'll just click and drag that little bottom right-hand square all the way down to autofill these cells. And again, I'll just check a few to make sure that they're correct. Nothing crazy happened. So here I have all of my within components. Now, if I want to sum my squared within components, I can simply add all of these up. So I can say sum, and I can add my different pieces here. Actually, you know what? Maybe I'll go on and start making my ANOVA table since I'm already kind of there. So let me move that out. Let's go on and make this ANOVA table. I'll have source. I'll label this ANOVA table. So my source, source. So for my source, I will have, I'll go and unbold these. I'll have the between. Remember, that's also called treatment, within, also called error, and total. So for my total sum of squares, I actually didn't calculate this, but for my total sum of squares, I would add up all of these different components, and maybe we should do that. And I would take their difference with the grand mean for the within components. I took their difference with the group mean, and now for the between components, sum of squares, for the between components, I'm going to take the difference between the group mean and the grand mean. Now this one's a little different because I actually do this for every data point, but it's every data point's group mean. So I'm going to, for this one, use the group mean minus the grand mean, and I'm going to square this. But the weird part about this is that both of these values are actually going to stay the same. For every cell, the numbers of both of these are going to stay the same for every number in this column. So I actually am going to get the same number in this column every time, because for each one of these values, I'm taking each one of these group means, that is 2.145, subtracting the grand mean and squaring that. Now, when I copy this over to the different groups, each group is going to have a different component. But for each one of these, I'm doing all of that again. So for each one of these data values, I'm kind of repeating this process. So each data value has its between component, its within component of variability. So for the within sum of squares, I'm going to sum up the squared terms for the within component, the individual value minus its group mean, quantity squared. For the between components, I'm going to sum up each of these values. For each data point, its group component minus the grand mean squared. And for the total column, I can quickly do this. So I'll just do total squares. I'll do total squares, I'll call it. And I'll take each data value. Probably could have done this first in organization. I apologize. Take each data value minus the grand mean. Now, and square that quantity. Now, when we do the grand mean, it's important to realize that for the grand mean, this is not going to move at all. So I'm going to add a $sign for B and for 13, because when I drag this over, I don't want it to change columns like it did for the within components. I want it to stay exactly at this reference cell. So I'm going to add both of those $signs there. And now I can drag over just like I did before. And when all this is highlighted, I can actually drag across to fill all that in nicely. Here, I'll type equals sum, open parentheses, and then I can add all of these different components up. Just like that. So here I'm looking at my between and my within and my total, and I'm seeing that these are supposed to sum up, but they're not. So I'm wondering what's going on. Looking at this, it looks like the between seems like the high one. So I want to go in and double check my calculation. Here I'm checking for each cell to make sure this is going correctly. I'll check for these cells, and I see that the second part of my subtraction, the red part, C13, is incorrect. What's going on is when I dragged this over, it changed which column the grand mean was in, because I forgot to lock that in with my B. So I can either go here, lock that in, and then update all these, or I can just go for this column, change that to be B13, and then lock this in for all of these components. So I'm just going to change these one at a time. Instead of D13, a blank cell, I'm supposed to compare to my grand mean B13, and then update here. After updating, I do see that these add together, so I feel pretty confident that this is working out. But that's a good quick double check on your work, and we mentioned earlier that double checking that can be pretty important in terms of understanding what's going on. So here, I could quickly double check my work by saying these don't add, the sums of squares don't add to the total. So how can I figure out what's gone wrong? And it's either the within, the total, or the between. The within and total seem to align, but the between seemed way bigger than the rest. And after a quick double check, I can see what's wrong with my formula and then update that. Note that because everything calculated in this is relational, after updating this, my ANOVA table has now updated, which is pretty handy. All right, so looking at this, my degrees of freedom, recall my degrees of freedom for the between is I take the number of groups, that's 3, and subtract 1, and that gives me my degrees of freedom for the between. Here for within, I take the number of groups, that's 3, and multiply by the total number of observations in each group, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I subtract 1 from the total number of observations within each group. For my total degrees of freedom, I take the number of groups, 3, multiply by the total number of observations in each group, 10, and then subtract 1 after I have that product. And again, I can double check that these are correct by making sure that they add up. In this case, thank goodness, it seems like I didn't make too many typos. For my mean squares, I'm going to go on and type equals. This is just the sum of squares divided by the degrees of freedom. And I can go on and drag this down because this is the sum of squares divided by the degrees of freedom for the within as well. Of course, I'm going to check this to make sure, given that I made a typo earlier. So I want to make sure that that looks correct. Last but not least, I can drop in my F test statistic. This is going to be the mean squares divided by the mean squares between divided by the mean squares within. And my F statistic is actually an immensely large F statistic. So I can calculate both the critical value and the p-value to compare to. I'll calculate the critical value quickly. The critical value we can find by doing the F distribution in Excel. So what we can do is we can give the F invert, where we give F the probability, and in our case we use 0.05. I use the RT to indicate we have the area in the right tail, so 5% of the area in the right tail. Here my degrees of freedom for the numerator are the top degrees of freedom is the first one I'm going to give it, and then the bottom degrees of freedom is going to be the second one that I give it. And for my F distribution, I give it 2 degrees of freedom. That first one between, and the second one will be the degrees of freedom within. Hitting enter, my critical value is 3.35. So clearly my test statistic is far, far, far above the critical value. To calculate the p-value, we do something similar. We're still going to use that F distribution, but we're going to use the regular F. So F dist RT. And now we're going to provide it with the F statistic from the table, the F test statistic. Again, we provide the top degrees of freedom between for the first one, and then the degrees of freedom error for the second one. Close our parentheses, and we get a very, very low F value, or a very, very low P value. Both the test statistic in comparison to the critical value and the P value in comparison to our alpha indicate that we reject the null hypothesis for this test. That is, for this test, we have enough evidence to believe that there is a difference between the effects of the dosages on the patient satisfaction in their daily life, which is the context of this problem. All right, well, this has been a demonstration of how to perform the one-way ANOVA using Excel.